Hello everyone, welcome back to the channel. I hope you are doing great. So today we'll be looking at another paper 1 question, and this is from winter 2018, paper 1-1, question 29. So why I picked this question? Because I find it really interesting because they give you 2 wavelengths instead of 1. So I know that the question, the picture itself can be a little bit intimidating, but actually it's really easy to do if you understand how it works. So without further ado, let's get to the question. A beam of light consists of 2 wavelengths of 436 nanometer and 654 nanometer. So 2 things to be aware of here. First thing, there's 2 wavelengths, of course, and the second thing is the unit. The unit is in nanometer. So when you are going to calculate later, and if you were to use wavelength in your calculation, make sure you convert nanometer to meter. Okay, alright, then they said a diffraction grating of 5 times 10 to the power of 5 lines per meter produces a diffraction pattern in which the second order of one of these wavelengths occurs at the same angle theta as the third order of the other wavelength. This whole thing is, what does this whole sentence even mean? It's so long. To put it simply, basically there's 2 wavelengths here. So one of the wavelength will diffract at an angle theta at second order, whereas the other wavelength will diffract at the same angle, but it diffracts at the third order. And the question wants you to find the angle theta. Okay, so let's begin by writing the formula. So we know diffraction grating has a formula of d sine theta equals to n lambda. Am I right? And you have this value here, which is the number of lines per meter, 5 times 10 to the power of 5. So in order for you to calculate d, you take 1 divided by the value, 5 times 10 to the power of 5. So whenever in the question they gives you per meter, per millimeter, or anything similar, make sure you calculate your d by taking 1 divided by the value, because your d is always in meters. So when you calculate this, you'll get 2 times 10 to the power of negative 6. So we have one value here in the d. So now we need to know which wavelength is for which order, and then we need to find our angle. Okay, so let's look at this formula. So in this formula, we can see that your d is constant, right? Because both of the wavelength goes through the same diffraction grating, therefore they have the same spacing. Your angle is the same because they explicitly mention here, same angle. Your number of order is not the same because one is diffracting at the second order and the other is at third order. And your lambda, of course, as you can see here, it's not the same. So what can we deduce from that? So we can deduce that n lambda equals to constant, because these 2 are the same, as in it's constant for both wavelengths. So we can safely say n is inversely proportional to your wavelength. So with this relationship, we can actually know which wavelength diffracts at which order, because from this we can see that the greater your wavelength, the lower your number of order. So if we look at the 2 wavelengths we have, ideally 654 nanometer is the one that is the greater wavelength, right? So that means 654 nanometer will diffract at the second order, because the greater the wavelength, the lower the order, and vice versa. The lower your wavelength, the greater the order. So 436 nanometer has basically the lower wavelength. That means it has a greater order, which is in this case third order. Okay, so you can actually use either wavelength to calculate and find your angle. I'll show you both to show you that the relationship is actually true, where the greater the wavelength, the lower the order, and we have actually put the right order for each wavelength, and to show you that both will give you the same angle. So let's start with 654 nanometer, not Newton meter, nanometer. So d sine theta equals to n lambda. Our d, as we have calculated earlier, it is 2 times 10 to the power of negative 6. Sine theta is what you want to find. N is 2. Your wavelength is 654. Remember, nanometer must be converted to meters. Therefore, times 10 to the power of negative 9. Then, you calculate, find your theta. Make sure your calculator is in degrees because all the answers are in degrees. If not, you might not get the right answer. So after calculating it, you will get 40.8 degrees. So let's just try with 436 nanometer and see if we actually get the same answer. Okay, let's try. D sine theta equals to n lambda. Your d remains the same. Sine theta, that is what we're going to find, and it is the third order. Your wavelength is 436 nanometer. Make sure to convert it, and let's see whether we get the same angle. And yes, we do get 40.8 degrees as well, and your answer is C. So you realize it's actually easy, right? Doable. The thing is, you need to understand how to use your formula. So first things first, we look at the formula and we determine what is constant. Then from what is constant, we can find a relationship, which is the number of orders inversely proportional to your wavelength. Then from that, we see which wavelength will diffract at which order. Then you use either 654 nanometer or 436 nanometer and you will get your angles. Also, don't forget to convert and make sure your calculator is in degrees. Other than that, you are all good. So if you realize, the question is actually easy. It's just that sometimes you look at the picture, it can be intimidating and you might think, oh no, this is a really hard question, and your mind will be blocked. So when you see a question, read the question first. Understand what they're trying to say. Because once you understand it, turns out you could do it. So always in exam, stay calm and read the question fully. Read it twice if it's necessary. Then I believe you'll be able to do it. So that's all for today. I hope you understand a bit on diffraction grating. This is a diffraction grating question. And I'll see you in the next one. All the best for your paper on 5th of June. Thank you. Bye-bye and have a nice day.